Welcome everyone to our video lecture series on fluid mechanics and machinery. In this subject, we will be seeing various mechanics in which fluid behaves and the application of fluid mechanics and the machines related to it. So in Unit 1, we will be seeing about the various fluid properties and various other laws concerning the fluid flow. So in this lecture, we will be seeing about units and dimensions. In the fluid properties, we will be seeing mass density, specific weight, specific volume, and specific gravity, and some problems related to it. So as we all know, matter is of three types: solid, liquids, and gases. Of these, liquids and gases are categorized as fluids. So as we say fluid mechanics, we will be dealing with the properties, mechanics of these liquids and gases. The liquids and gases are collectively known as fluids. It's all well-known fact. And fluid mechanics, what is it? It's a branch of science which deals with the behavior of fluids, which is at rest as well as in motion. So we'll be dealing with both conditions when a liquid is at rest and when a liquid is in motion. So how the liquid behaves, or how a gas particle behaves when it is in rest or when it is in motion. And this fluid mechanics can be classified into two types. One is statics and another one dynamics. So as we said, study of the property of fluid in rest or in motion. So statics is the study of fluid at rest, and dynamics comes under study of fluids under motion. And this dynamics can be further classified into kinematics and kinetics. So kinematics means study of the motion of fluids without considering the forces which cause this motion, such as pressure force. In some cases, pressure force may cause the motion of particles. So we are going to study the motion of fluid particle, but we are not going to consider the force which caused this motion. So such study is called kinematics. Next one is kinetics. So kinetics is the study of fluids in motion with the consideration of the forces which is causing this motion. So this is our broad classification of fluid mechanics, and we'll be seeing all these in our coming chapters. So units and dimension, this is a well-known thing which we have studied in school itself. So just brush up about this a little. So there are three types of units. One is MKS unit, another one is CGS, and now it's commonly adopted SI system. So some parameters and their units in CGS, MKS, and SI unit with dimension. So mass in CGS system, the unit of mass is gram. In MKS system, it is metric slug, MSL, it's denoted. And in SI system, you all know it's kilogram. And dimension of mass is capital M. And for length, CGS unit is centimeter. And in MKS and SI system, it is meters. Dimension of length is L. For time, CGS unit, MKS and SI unit, all is seconds, and the dimension is T. For acceleration, in CGS system, it is centimeter per second square. For MKS system, it is meter per second square, and in SI system also, it is meter per second square. Dimensions is LT power minus 2. Force in CG system, it's 1 dyne, which is gram centimeter per second square. For MKS system, it is kilogram force, which can also be denoted as MSL, meter per second square. In SI system, it is Newton, which is kilogram meter per second square. And dimensions of force is MLT power minus 2. So 1 metric slug is 9.81 kilogram. And we all know 1 Newton is 1 kilogram meter per second square. from this we can get 1 Newton is 10 power 5 dyne, and 1 kilogram force is 9.81 Newton. So these are some conversions which you may see. In the following we will be using some more conventions also, so go through it. Properties of fluid. So some properties of fluids are mass density, specific weight, specific volume, specific gravity, viscosity, compressibility, vapor pressure, surface tension, and capillarity. So these are also well-known definitions which you use broadly in science. So we'll be seeing one by one in the following slides. Mass density. We all know the definition of mass density, or simply we call it as density, is mass per volume. So mass of the fluid per unit volume is mass density. It's denoted by the Greek letter rho, and rho is equal to m by v. For rho of water is 1000 kilogram per meter cube, or 1 gram per centimeter cube. This mass density increases with increase in pressure and decreases with increase in temperature. Specific weight or weight density or unit weight. So it is the ratio of weight of a fluid to unit volume. That is, weight of a fluid where unit volume is denoted as unit weight, and gamma, it's denoted by the letter gamma. Gamma is equal to W by V. Gamma water is 9.81 kilonewton per meter cube, or simply 9810 Newton per meter cube. You know gamma is equal to rho into G. Specific volume, volume of fluid per unit weight. So volume of fluid per unit weight is represented as specific volume. For gases, specific volume is 1 by rho, 1 by rho, which is density, volume of fluid to density. So that is denoted as for gases. So for gases, it's a reciprocal of density. For liquid, it is a reciprocal of unit weight. Specific gravity. Specific gravity is the ratio of weight density of any fluid to the weight density of a standard fluid. Specifically in case of liquids, it is water. So it is denoted, we know it is gamma liquid by gamma water, and specific gravity of water is 1. Since the standard fluid is water and the numerator is also water, it is 1, and most of the oils has a specific gravity of 0.8. Specific gravity of mercury is 13.6. So let's see a problem. Problem is to calculate the specific weight, density, specific gravity of 1 liter of a fluid which weighs 7 Newton. So here they have given us the volume of fluid which is 1 liter. So 1 liter is 1 by 1000 meter cube. So well, let's keep in meters since we'll be using metric unit, that is SI unit will be using, so let it convert and keep it in meters. Okay, the weight is 7 Newton. Now specific weight is weight by volume. So we have got a weight of 7 Newtons and the volume is 1 liter, which is 1 by 1000 meter cube. So we get 7000 Newton per meter cube. Now density is mass per volume. Right. So and weight so we know gamma is equal to rho g. mass equal to weight is mass into gravity. So from the given weight we can get the corresponding mass, which is 7,000 kilogram, and density is 8 by gravity we have given, and 7,000 by 9.81 we get the corresponding answer. And for specific gravity, we know it is density of a liquid to density of water. Density of water is 1,000 kilogram per meter cube, and the density obtained here is 713, and we get the answer as 0.71. So similar problems will be asked, so go through such problems, and thank you.